Hey, so I just wanted to first off thank you for letting me be in your documentary that you're recreating about X-rays, and you wanted to see how my research has played a part in it. So I'll go ahead and start off. So your first question was just who I am and what my project's all about. Well, my name is Arthur Compton, and I'm known for creating uh, or discovering X-ray scattering, or Compton scattering, X-ray scattering, all the same thing. So Compton scattering, yeah, is actually quite simple. It occurs when an X-ray photon is deflected from its original path by an interaction with an electron. The electron is usually one of the outer electrons, so that way it can be shot out from its electron orbit easier. Because if it's closer in, it can't be shot out easier because it's pulled in more to the nucleus, while the outer ones are not tightly bound as much, I guess. And so the chosen electron is then shot out from its original position in orbit. And then because of that, the photon loses energy, or the X-ray photon loses energy. However, it continues to travel through the material along an altered path. So let's say you fire the photon from the X-ray straight, it would hit the electron, but then it would bounce going, let's say, diagonally right, while the electron could be shot diagonally up and left. So it just, makes the path a little bit different. So your second question was what we were trying to do or find exactly? Well, what we were really we were wanting to prove, enforce really, that light has wave-like and particle-like properties. That was something that Einstein thought about, and I was wanting to see if we could further solidify that, and my research has. So that's what we were trying to do. So you want to know where the project occurred? It's been a little while since I've done the project, but I believe it occurred over at where I was studying at Washington State University of St. Louis in one of the labs there. So, yeah. So you also were wanting to know, just I guess as extra little information for your documentary about other significant events that were happening around the world at the same time. Well, so this is around in the 1920s my research was going on. So the first, well, I'm trying to think what was going on at that time. Oh yeah, that's right. The first antibiotics were created, which was really huge for the medical community. Most of these aren't really related to physics stuff, but mostly like medical, because medical science is advancing very fast at this time. And then several different types of vitamins were discovered, and this is actually pretty big. Sound was finally added into movies, which isn't really science, but it's still a very big deal because something we just expect to have in videos and whatnot to this day. And then also the lie detector was created. So, your fifth question was who else was involved in the project? Well, J.J. Thompson and William Dune, they helped further my research. They weren't directly involved, but they played a support on the outside with it. And then not only that, Samuel Allison, he, like them, didn't really directly help. He helped in a different way. He helped revise my book, which was entitled X-rays in Theory and Experiment, so showing how X-rays could work and how they actually work. So you're wanting to also know what my role in the project was. So my role was to make sure the project just ran smoothly. I was, charged with research. I was charged with setting it up, make sure it worked. So I would set up the experiment exactly how it needs to be set up, so that way it would, work. And then once it all was set up properly, I'd fire the X-ray protons onto the electron and record the results. So pretty straightforward, nothing too terribly complicated. Once that was done, my assistants and I would just go over our findings, see what we learned, and then we learned that it was, what light is wave-like and particle-like. So there we go. You want to know what impact it had on the physics community? Well, first off, it showed that light has both wave-like and particle-like properties, which I know I've been restating a lot, but it was truly a big deal because for the longest time, people thought light was one or the other and not both. And then Einstein said, well, it's both. And then I come along and show that it truly does meet the qualifications of both. However, it's really been huge in the medical community, medical science, more specifically for radiation treatment. And your eighth question you were wanting to ask me, well, if I am a religious person, well, yes, I am. I think that even if you are a man of science, you can still, have faith in religion. I am a Christian, after all. My father was a pastor at a local church, and I almost became a missionary. I was very debating on if I should but pursue further into science, and then pursue into mission work. And my father told me to just pursue science because he knew that's what I truly deep down wanted to do, and he believed that it would help even the Christian community and my faith even more if I, studied physics. And I did a lot of great things, proved that light is particle-like and wave-like, and to be able to get a Nobel Prize in the process. So that's pretty cool. Anyway, thank you.